Hello, everyone. In this lecture, we are going to talk about alternatives to experimental designs, experimental studies. So, as we have seen earlier, experiments are great at investigating causal inference. So, to making causal inference. So, if you have a proposed variable that is a cause, then you can investigate its effect on an outcome with an experiment. And in an experimental study, we would manipulate the cause. That is, we would make sure that there is an intervention group, for example, which gets the intervention while the control group does not get the intervention. So this cause variable, which is getting or not getting the intervention, is manipulated by us, the researchers, directly to make sure that this is a true difference between the groups and that there is no other difference between the groups. However, so we have seen the benefits of this kind of experimental method in the earlier lectures. And we have seen that when combined with random group allocation, it can be a very powerful method to rule out many different forms of biases. But there are many cases where experiments are, and experimental studies in general, so experiments and quasi-experiments, are not ideal. For example, if the manipulation of the cause is not ethical. For example, we might be interested in the psychological effects of the COVID-19 infection on people, but it would be hardly ethical to infect people with coronavirus just to find out whether this would have differential psychological effects on them compared to people who are not infected. So this is one example. Another example might be if it's too expensive to manipulate the proposed cause. So, for example, we might be interested in the psychological effects of long duration space missions, and it is very expensive to send someone to space. So it is not really a feasible thing to do an experiment there where we would have group of people who would launch to space just to find this out. And of course, it's also possible that the outcome that we are interested in is very rare. So let's say we are interested in the relationship between smoking marijuana and the development of schizophrenia. It is proposed that smoking weed might make people more prone to developing schizophrenia, or rather nowadays we think more like this might be a trigger that could trigger schizophrenic symptoms early. But if you're interested in assessing this relationship or this causal relationship, then it would be extremely hard to do this in an experimental study because schizophrenia is quite rare in the population. So you would have to have hundreds and hundreds of people, and not to speak of, it wouldn't really be ethical to make them use marijuana in the long term in an experimental study. So in these cases, it is not really ideal to use an experimental study, and we might turn to other alternatives or the other types of study designs. So there are some observational studies that are directly addressing these issues. For example, cohort studies and case control studies are study designs that are often used to answer these similar kinds of questions. When I'm saying observational studies in relationship to cohort studies, case control studies, I'm referring to the classification by Song and Chung, which is one of your required literatures readings. So if you look at the studies group book, there you would find a mention of cohort studies among experiments, but whenever I ask about observational studies in the exam, please use the Song and Chung characterization or categorization, and I usually make that clear even in the exam questions as well. Okay, so the observational studies are different from experimental studies in that in the observational study you are not manipulating, the researcher is not manipulating the cause. The researchers are more observing something that's naturally happening in the environment. So in this lecture, we are going to focus on cohort studies and case control studies. We have already seen cross-sectional studies in another lecture previously. So in this video, I'm going to focus on cohort studies specifically. So a cohort is a group of people with a specific set of characteristics. So a group of similar people, basically, who are followed over time, over a long time, usually to determine incidence of an event or a disease. So, for example, we might be interested in who would, or whether smoking would have would be a risk factor in the development of different types of lung diseases or chronic diseases related to breathing. So this is a very classical example for cohort studies. In order to explain this well, we are going to start very early, this example cohort study. So let's say we are interested in whether people who start smoking in high school or earlier would be more at risk of developing specific types of lung diseases and chronic diseases compared to those who don't smoke during high school. So in this case, we might use a cohort of high school students who are in a specific, go to high school in a specific region or district. So that would be our cohort. And we would start following this cohort very early on, maybe before any of them are smoking or before a lot of them start to smoke. And then some of them might start to smoke, some of them will not smoke at all during high school. And we would follow them over time, over a long period of years, and register which one of them would show symptoms of different lung diseases like COPD or lung cancer or asthma and these kinds of diseases. So we would use their hospital records, with, of course, with their consent, to do this. And what we would do in the end is compare the group which versus the smokers and the group who were the non-smokers during high school to see whether there's a difference between the incidence of these different lung diseases. And if we would find a difference, let's say the smokers would have a higher incidence of these diseases, we would have a good evidence supporting that smoking is a risk factor for these development of these lung diseases. This is the main idea of a cohort study. So in this cohort study, I've already talked about what the cohort means. The cause is usually, the proposed cause is usually called an exposure. And so those who are who have the cause are usually called the exposed group, and those who don't have the cause are usually called the non-exposed group or the not exposed group. Okay, so this is an important nomenclature that we call exposure, the presence of the cause in one of the groups, and the absence of the cause we call non-exposure in the other group. Okay, and in reality, in practice, it is much more common to not start following this cohort so early on. So the researchers would instead start the follow-up when people are already exposed. And the reason for that might be that the cause itself is rare among the cohort, or and so it is easier to get a decent number of the exposed people once they are already exposed, and then you can select a matching set of people who are not exposed. And the other reason is that those who are in the exposed group might have some other variables that are different in them, which make them more prone to be exposed than the other group in the cohort. So you might have to adjust the cohort to be more matching to the exposed group. So this might be another reason for starting this study when people are already exposed in the exposed group. Okay, so this is the main idea of a prospective cohort study. We call this a prospective cohort study because it looks forwards in time. So when we start this study at one point in time, and we follow people over time. And we will see another example, which is another study design, which is called a retrospective cohort study, where we look backwards in time. We start this study when people already have the outcome, or the proposed time already elapsed, and we see we get our groups backwards in time. Okay, we will look at that. But first, I wanted to talk about one big weakness or one big limitation of cohort studies, which is that the cohort studies are very vulnerable to selection bias. So what I mean by that is selection bias means that the groups are fundamentally different from each other before the cause is manipulated, or they have fundamental differences among the groups that would bias or causal inference. Let's see an example. So we are interested in the effects of binge drinking in high schoolers on developing alcoholism later in life. So in this case, we might get a cohort which are just from general high school students in a specific region. And then we would see which one of them are exposed, which one of them are not exposed, so which one of them can be characterized as binge drinking or binge drinkers, and which one of them are not binge drinkers, and then follow them over a certain period of time, see whether they are different in developing alcoholism. The issue here is that binge drinking might be due to some other variables. So some other variables might make people more prone to binge drinking, which these variables would be also related to the outcome of interest. So it is possible that the binge drinkers would have different family backgrounds, maybe more of them would have like divorced parents. It is also possible that they are living in a different neighborhood with a higher probability, or they would have worse school grades, and they would have different career prospects. So when we get to the follow-up time, it might happen that these different variables that also made people more prone to binge drinking would also make these people more prone to developing the outcome of interest, that is alcoholism. So while we would see that binge drinkers have a higher number of alcoholics among them after the follow-up period is ended, but our causal inference might be biased, because it's actually not binge drinking that causes the development of alcoholism, but maybe this is a combination of some other variables like the family background, the neighborhood, the type of jobs that these people would take, and so on. So to prevent this, it is extremely important in cohort studies to take good care of selecting the right control group that matches the exposed group. So that is one of the other reasons why you would start this study when you already have your exposed group. Then it is much more viable to select a matching set of control participants who are not exposed but are matching in all the important other characteristics like family background, neighborhood, school grades, career prospects, and so on. So this is very important in core studies and observational studies in general. Okay, so even more common are retrospective cohort studies. In the retrospective cohort studies, the researcher would start the study when the follow-up period basically is already over. So the study would be started when there is a good chance that the outcome of interest has been developed in the group. Let's say you are interested in whether victims of sexual abuse or sexual assault would have a greater risk of being hospitalized for mental illnesses. And what you would do is go into some registry, let's say police registry, which would have a group of people who have reported been the victims of sexual assaults. You would contact these people and ask them to join the study. But this would be, let's say, 10 years or more after the crime happened. And you would ask them for access for their medical records, or you would ask them simply to report on whether they have been hospitalized for the specific type of illness that you are interested in. And the study is basically over there. So you are not doing a long-term follow-up of these people. The follow-up period is already over when you have started the study. So you rely on already existing information about the cohort. And you would also have another set of people from the cohort who are not exposed, so who are not victims of sexual assault, but are matching in every other important characteristic that would be correlated with the outcome of interest. So, as we have seen, cohort studies are great at determining the incidence of a specific event or a disease, a development of a disease. And one other advantage is that you can look at multiple outcomes which might be moderately rare, or which might take some time to develop. So in an experiment which is not a longitudinal study, you only have certain amount of time during which you can look at the outcomes, and thus it is more restricted what are your outcome measures. In the cohort study, the range of outcomes that are accessible to you are more various in this case. Okay, and it's also an advantage that the cohort studies are good for investigating rare exposures, rare causes. So you could even do a cohort study on the effects, long-term effects of being struck by lightning. This would be completely unethical to manipulate as a cause. You don't want to strike people with lightning just to figure out its long-term effects. In a cohort study, you could have a cohort of people who are recently struck by lightnings all over the world, and you could follow them over a certain period of time. Or you could do a retrospective cohort study where you would follow up with people who have been struck by lightning in the past, and see what sort of effects they have experienced in their lives. It is also more ethical for the stated reason. So you are not manipulating directly the cause, and if the cause is actually risky in some reasons, for some reasons, then it is more ethical to just observe what's naturally happening. So you are not really intervening here. But still, you could be even unethical with a cohort study if you know of something definitely that it is a risk, and you could do something to stop people from being exposed. Then you would be obliged to stop them from being exposed. So in some cohort studies, they are actually actively using some interventions or providing some solutions for people in the exposed groups. For example, if they want to stop using a specific drug, they would get instructions on how they could stop this habit, but they would follow those still who would not use these instructions or these interventions that are provided for them. There are also some limitations, as we have seen for cohort studies. So it's usually a large number of subjects or participants are required to study, especially for rare outcomes. So if you are interested in, as we have seen, development of schizophrenia due to using marijuana, you would have to have hundreds and hundreds, probably thousands and thousands of people just to get a significant result in both the exposed group and the control group, because schizophrenia is just so rare in the general population. And as we have seen, selection bias is a big problem or a big threat of bias in cohort studies. In prospective cohort studies, specifically, the problems come from it being a longitudinal study, which is more expensive to do, requires a long duration of follow-up during which people can drop out of the study. The study group might lose funding over time, or the researchers might even lose interest in the subject matter. So this is the main limitation of prospective cohort studies, aside from the ones mentioned above. And for retrospective cohort studies, the problem more comes from the restriction of what information is available for you at the time of the study. So because you didn't start the study at the time of exposure, but you are starting the study at the end of the follow-up time, you don't have any control over what are the variables that we are collecting. You're only that are recorded, more like. So you have to rely on information that is recorded naturally, like hospital records, police records, or you have to rely on the memory of the subjects, or people in the study, to be able to reconstruct things that happened from between this time of exposure and to this time, to the end of the follow-up. So this is the end of the video about cohort studies. In the next video, we are going to talk about case control studies.